Nothing strikes fear into the heart of programming students more than pointers. But what I want to do here is demystify pointers and talk to you because they're really quite simple. The concept is simple. A pointer is a memory address. That's all it is. It's just the address of something in memory. So it's useful because it lets us talk about where data is stored in memory, and that's sometimes useful. And an also useful thing about pointers is if we have a collection of data that's stored in a place in memory, then we can refer to that, we can share that information just by giving the location of that data and not a whole copy of everything that's in that place. Now we've already used pointers a good bit. We used them in 109, we used them, R5 points to the activation record, we've used them with scanf, so whether you realize it or not, you've already been using pointers. And I just want to talk about the explicit things that C gives us to manipulate pointers, which makes it a little different than some other languages that you might be used to. So fundamentally, C provides us two new operators to deal with pointers. And unfortunately, these operators use symbols that we're already using for other operators, but these are unary operators, so they won't be confused with the binary and multiply operations. So the ampersand is what we use to take the address of something, and the star is what we use to dereference a pointer, and I'll explain those as we go. So just remember, a pointer is a memory address. So let's say we have a variable x. I've told you before that every variable has a memory location associated with it. This one happens to be an integer and it has the variable 97 stored in that memory location. So when we say x in a C program, what we are referring to is the value that's stored in variable x's memory location. Right? That's what we've been doing. If we apply the ampersand operator to that variable, so now we say ampersand x, the address of x, the value of this expression is not the content of the variable x, but it's the address of variable x. It tells us where in memory this box is located. So if we want to know where x is, we have a variable x, we use the ampersand operator to give us that value. And then we can use that value for other things. Like I said, we've already been using this, and I told you it was magic before, but now we're going to explain what it is we're doing and why we do it. When we call scanf, remember scanf goes out to the user and looks for a decimal integer in this particular case. So it reads characters, converts those characters into a decimal integer value, and then what do we want to do with that value? We want to store it somewhere. We want to store it in this variable called input. So if I told the function without the ampersand, right? If I just told it about input, I would be talking about the value that's stored in input. So instead we use the ampersand operator and tell scanf where we want the data to be placed. We don't care, scanf doesn't care what's in that box right now. It's going to replace it with whatever it reads from the user. And so when we call scanf, we don't tell scanf what's currently stored in input. We tell it where input is, because that's where we want scanf to put the value that it's going to get. So that's a use of the ampersand operator. Now there are more sophisticated things we can do, and C allows us to actually have variables that contain pointers. This is where the power of pointers comes in C. And how do we talk about a variable that holds a pointer? Well, its type is pointer to something. The star in a type declaration means pointer to something. So pointer to int, pointer to car, pointer to double, pointer to int pointer, lots of different things we can point to. But the compiler needs to know not only is this variable a pointer, it holds the address of something, but we want to know what kind of thing is it pointing to. The compiler needs to know that. So here's how we declare a pointer. Int star p, right? That's the declaration ending in a semicolon. That would be enough to be a declaration. Here I've shown an example where we've declared an integer, x, and we initialized it to 97, and then we declared another variable p. P is a variable. It holds a pointer to an int. Okay? So its value, we don't usually write the actual memory address in there because, number one, we don't know what it is when we're just doing these examples. It's somewhere on the stack or somewhere in memory. And number two, we don't really care what the actual address is. We just want to know, we want to represent what it is that p is pointing to. So when we say initialize p with the address of x, I draw this with the little, make sure to put a heavy dot there to say the content of this box is a pointer to that box. Okay, so p holds the address of variable x, which means that the value in this box is the address of this box. And we're going to use star for another reason as well. If it's not part of a declaration, then we use it as the dereference operator. So we use the dereference operator to take a pointer and follow that pointer and access the value that it points to. So if we have this is the example we had from before. We have a variable x and a variable p that contains a pointer to x. Okay? So if we say p in our program, we're talking about this value here, the actual address, right? The value stored in variable p's memory location. So p is this value, whatever it is, and it's just a number, right? It's an address. But if we say star p, we're referring to, we take p as a pointer and we follow that, we use that address, and star p is the value that's stored here, where p points to. Okay? So star p is the value stored in the memory location pointed to by variable p. So when we see star p, we're following a pointer. So we start at p, we get this value, we go to that address, and then we see that value right there. And we can use star p on the right-hand side or the left-hand side of an assignment statement, as we'll see. Okay, so finally here's some examples. Let's say I've got these variables declared. So p1 is a pointer to an int, p2 is a pointer to an int, p3 is a pointer to an int. We haven't initialized them with this declaration, and val is an integer value. So here I've got boxes for each one of these, and I've just arbitrarily shown what p and p1, p2, and p3 point to, just for the sake of an example. Right? We don't know how it got to be this way, but if there's a value in here, and there always is a value, we interpret it as a pointer because that's what we said is going to be stored in this boxes, and it points to something. And if it doesn't point, we don't know what it points to, we can draw this. Here I'm assuming it points to some other memory location that holds these values here, just for the sake of this example. Right? This declaration doesn't do this, but it does this part. So let's see what happens when we execute these statements. So here we're assigning p1 to the variable p2. And what does that mean? It means the same thing as any other assignment means. The value of p1 gets stored into the location for p2. Well, the value of p1 is a pointer. So we don't take 23 and put it in here. We put this value, which is a pointer, and we copy it into p2, which means that now p2 points to the same memory location. It has the same value, the same address as here and here, so they each point to this other arbitrary memory location. Okay? So when we do this, we're copying the actual pointer. If I do val equals star p1, Okay, star P1 is not the content of P1, it's the content of where P1 points. So this would go to P1, follow this pointer, go to this address, and load this value, 23, and that's what would be placed here in Val's box. Okay, so we've done this one, and we've done this one. Now, here's a weird one because we've got this expression on the left-hand side of an assignment statement. And before we've always had just variables over there. But this makes sense because we're storing a value not into the box P3, but into the place where P3 points. So we can dereference on the store side as well as on the load side. So this would take the value of val, which is 23, we add 1 to it, right? So this expression is 24, and we assign that to the place where P3 points. We assign it to star P3. So that will change this memory location to 24. P3 didn't change at all. We're changing the thing that P3 points to. Okay, so now we've done that. Now let's just have a case where we have dereference on both sides of the assignment. So star P2 equals star P3. Star P3, we always do what's the expression on the right hand side. Well, star P3 is the value that P3 points to, which is here, 24. And we're going to store that into the place where P2 points, not into P2. We're not going to put 24 here, we're going to put 24 here. Okay, so that changes that memory location. And again, remember that P1 and P2 both point to this, so if we dereference P1 later on, we will also get 24. Just like if we dereference P2, we get 24.